Here we go with number 3. We have 380,000 tons. And once again, a ton is 1,000 kilograms. There's no, it only just says, oh, it says per month. So tons per month. All right, so we need to change it into cubic meters. Now in this problem, we have density given to us. The density of aluminum is 2.7 grams per cubic centimeter. So once we change our tons into kilograms, which is bigger, by the way, a ton or a kilogram? Ton is, so it gets one of those. Then we can go to grams. By putting kilograms down here and grams on the top. So 1,000 grams is 1 kilogram. All right, at this point, we're going to need to use the density. Since the density is given in grams per cubic centimeter, right here, grams per cubic centimeter, we will need to change the mass into grams, and that's what I just did. Now we're going to use the density, but instead of writing grams per cubic centimeter, we need to write grams on the bottom and cubic centimeters on the top. So that's going to be cubic centimeters per gram. But we know that because it tells us right here that 1 cubic centimeter is 2.7 grams. All right, we're going to assume the 1 cubic centimeter is a definition, but the 2.7 limits us by sig figs to 2 of them. All right, then we're ready for the last step, cubic centimeters and cubic meters, and one of those is 1,000,000 of these because it's cubic. Once again, it's 100 times 100 times 100. So on that one, I actually had to break out a calculator and do this one. So give me a moment here. I'm going to do it on the side on my phone. So I've got 380,000. I'll tell you what I'm writing in, 380,000. I'm going to multiply that by 1,000 and then also times another 1,000. And on the top, I get 3.8 times 10 to the 11th. Then I divide that by everything that's on the bottom. So I'm going to divide by the 2.7, you can see right here. Then I'm also going to divide by 1,000,000, which you can see over here. So this is the 1,000,000 on the bottom. So I end up with 140,740, which is the same as, how many sig figs here? 2, 2, 1, 4, 0, 0, 0, 0. So you have to round off to 2 sig figs, so it's just 140,000. And the unit is cubic meters per month. I didn't mention the month up ahead, or up above, I mean, but the month didn't cancel. It didn't need to because it asked us how many cubic meters are there per month. All right, that was number 3. Number 4. You got excited atoms traveling at 2 times 10 to the 3rd kilometers per second. So 2.0 times 10 to the 3rd kilometers per second. Kilometers here. I'm going to convert it to miles per hour, so I really need to change kilometers per miles. Now you could go real long on this. Man, I'm tired. It must be the end of the day. I'm getting tired. So here, hang on. So take this out. This should be meters. Kilometers. So kilometers are here, so kilometers are here. You're probably wondering about that. Okay, so miles and kilometers, which is bigger? A mile is. Now you may not know this relationship off your head, top of your head, and I don't expect you to, but it's a mile, we're going to say is 1.61 kilometers. All right, so now we'd have miles per second, we want miles per hour. So you're going to put seconds on the top. I'd put minutes on the bottom. So which is bigger? A minute is. So 1 minute is 60 seconds. Then minutes on the top, hours on the bottom, which is bigger, hours, 1 minute, 1 hour is 60 minutes. So now I have 2 times 10 to the third times 1 times 60 times 60, then divide by 1.61. So 2,000, 2 times 10 to the third, times 60 times 60, 7,200,000 divided by 1.61 equals 4,472,049.69. But given that this only has 2 sig figs and this has 3, this has infinite because they're definitions, so I have to round the answer off to 2. So I'd say it's 4.5 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th. The unit would be what? Kilometers canceled. Oops. A little glitch there. So kilometers cancel right here. Seconds cancel here. Minutes cancel here, so you're left with miles over hours. All right, next one's a little bit confusing and also very easy. On this one, it always helps me to write down what I'm looking for. So milligrams per milliliter is what I want. And the units I'm given are milligrams, or I got fluid ounces and milliliters. So I want milligrams per milliliters. So I'm going to need milliliters on the bottom, so I'm going to leave that. See, and I got milliliters up here. So I know I've got 32 fluid, or 946 milliliters, I guess would be the way I would look at that. 946 milliliters. Oops, that's wrong. Setting it up wrong. Okay, you want milligrams per milliliter. So you need to get rid of milligrams. You know that there's 7.5 milligrams per fluid ounce. So let's write that down. 7.5 milligrams per fluid ounce. So we need to get rid of ounces. So we put it up here and put milliliters down here. So now we would have milligrams per milliliter. It's really just a one-step problem. So the number of ounces, you've got 32 ounces, is equivalent to 946 milliliters. So 7.5 multiplied by 32 divided by 946, 0.25. It's actually my answer is 0.253699979, but we know that's really not a accurate answer because the calculator is giving us too much information. It's making assumptions. So we know this number has 2 sig figs, this number has 2 sig figs, this number has 3 sig figs. The answer can only have 2 because that's the factor with the least. So it's 0.25 and the units are milligrams over milliliter. That brings us to the last question. So you've got 3 times 10 to the 4th kiloliters per day. Kiloliters measures what? In that volume. And you want to know how many metric tons, which is mass. So when you're dealing with mass and volume, trying to change one to the other, you're going to use density in the middle. To use density in the middle, you got to know the density of water. So we know that we have a kiloliter, we're going to change it down to milliliters. So I'd put kiloliters here and liters here. And I'm changing to milliliters so I can use the grams per milliliter conversion. So 1 kiloliter, 1,000 liters. I want to go to milliliters, so put liters here, milliliters here. Liters are bigger, so We have that. Now we're ready to use the density. This time we can use it right side up because we got milliliters here, so we put milliliters here and put grams on the top, 1 grams, 1 milliliter. We want tons, so we got to go from grams. I go to kilograms first. I'd put grams here, kilograms there. So one of these is 1,000 of those. Now you need tons. What's going to go on the bottom? It's kilograms. And remember, when we do kilograms, tons are bigger. There's 1,000 kilograms in a ton. So that now we have in the numerator, we have tons, and that's what we want. We want, on the denominator, we want years, because we want to know tons per year. So I need to get rid of days, so I'm going to put days on top, years on the bottom, and 1 year is 365 days. And now you do the math. We could simplify the math a little bit by saying this 1,000 cancels that 1,000, and this 1,000 cancels this 1,000. So then all we really have left to do mathematically is this number, the 3 times 10 to the 4th. Divided by, divided by 1. I forgot, it's really multiplied by. Since this 365 is on the top, we have to multiply by 365. So my final answer is 10,950,000, 10,950,000. However, that number has 3 sig figs. So we need 3 sig figs. So 1.10 times 10 to the what? 1, 2, 3, 4, 5, 6, 7. Tons per year. All right, so that was that problem. So I'll make another movie about the textbook problems.